Welcome to part 2 of my series where we'll be discussing how to do testing using a domain-specific language that is powered by Gherkin, Cucumber, and SpecFlow. So what we talked about last time is some of the basics on the philosophy, and today we'll be talking about some of the details on how you're actually going to make this work. So, first up, variables. Variables are part of pretty much every programming language out there. And they make functions work, they make classes work. Without these things, a lot of things would not be possible. So we want to add these variables into our domain-specific language, which will make it much more powerful. So let's look at the scenario below, where we'll be talking about how we're going to build an organizational chart, right? It's going to have a boss, some managers, and a bunch of reports. And we're going to see what would happen to that organizational chart if we retire one of these people. So in this particular case, we have one boss. He has two managers and an assistant reporting to him. Then the first manager has two direct reports, and the second manager has one direct report. And now we're going to see what happens if we retire manager 1. Well, then we can say that the boss has 4 reports. Now there's something we did here. We have a variable called boss. We then refer this as the manager of other employees. And we use it again down below in these steps. What we've just done is create a fairly complicated structure, right? We have 3 different layers in our organization, and we've done that using just a single step, given the employees. But by the magic of having these variables available to us, now we have the ability to actually build this out and refer to it later on. If we want to, we could actually simplify it a bit more. We can just say given the employees, and now we say, okay, we're going to have a boss who doesn't have a manager. Manager 1 reports to boss, manager 2 reports to boss, assistant reports to boss, report 1 reports to manager, report 2 reports to manager, and report 3 reports to manager 2. We retire manager 1, and the boss has 4 reports. This is again something that is very simple, but it's very powerful because we can model a lot of different organizations. We can see what happens if a lot of different people retire. And we can check what the direct reports are for anyone in this structure. This is where variables come in, and that's what we're going to try and build out. So here are the scenarios we'll actually be implementing. In the first scenario, we'll be talking about how we can handle resolution. So we're going to talk about a domain object. It's going to have an ID, a name, and a parent. So the first thing we want to do is we want to be able to say that we can use a dot notation for variable resolution. So given the domain object, var do1, name Bob, ID 42, then do1.name equals Bob, and do1.id equals 42. This looks like it's reasonable, right? This is something you would see if you were normally writing C# code or C code, or pretty much most codes will follow this behavior. But this is something we're going to have to teach our code how to do. The second part, we want to be able to set values, right? So this would be something where we're going to create an object, and then we're going to get the ID back, and we want to make sure we keep a hold of that ID for the rest of the test. So given the domain object do1, then when do1.id is set to 42, then do1.id equals 42. Again, very simple, very primitive, but it's something we're going to have to build to make it work. Next thing is we want to be able to navigate through these properties as a hierarchy. So we're going to have a domain object. It's going to have DOP, which has the name of parent. Now we're going to have a DOC, which is going to be a child object, which has a parent of DOP. Then doc.parent.name equals parent. Again, what we've done here is we've created a simple scenario which tells us that we should be able to navigate through these objects the same way as you would in any other language. Next up, table input. We're going to have a lot of table inputs in the way that we're going to build this, primarily around the concept of domain objects in your application. So depending on what your application is dealing with, that will determine what your domain objects are. But most applications have at least a number of them. So the first thing is, what happens when somebody enters a column that doesn't exist in our domain object? Right? We want to be able to say that, hey, the field wrong was not found, and we want to give a suggestion as to what would be a possible field. So in this particular case, the only one that isn't specified is parent. So we want to offer that suggestion to the user, and the user being the person who's actually writing these tests. We also want to be able to handle scenarios where we have multiple options that are possible, right? So in this particular case, ID isn't specified either, and it will say, well, did you mean ID or parent? And the last scenario we want to deal with is if we have an integer and we pass in a string, we want to be able to say, hey, that wasn't possible to turn into an integer. Now, as you see, we're just doing these given steps, the same as we saw before. But these would error out normally. Now, one of the things we're going to do is we're going to put an extra layer of error handling on the application. And this is the step up front called given an error is expected. And what we're doing here is we're effectively creating the functionality of a try-catch block, because this allows us to reuse the same steps again. By default, whenever the domain object will run, it will throw exceptions, and it will stop the test if it fails. But if you're trying to test invalid scenarios, we want to reuse the same steps by putting a level of error handling on top of it that we can configure on how it's going to behave. We also want to be able to handle resolution errors. We want to be able to say that if you pass an unknown variable, it will just say like, hey, I wasn't able to resolve this variable. If you have a path specified, like in this particular case, we have doc as our child domain object, doc.wrong is set to 42, it will actually say that, hey, I wasn't able to resolve wrong, but that was part of the doc.wrong. It could be ID, parent, or name. And we also want to be able to dig again. Right, so in this particular case, we want to say doc.parent.wrong is set to 42. Well, I wasn't able to resolve wrong of the part doc.parent.wrong, but here are some of the suggestions. It is very important to have useful error messages for the people writing these tests for this to be a successful language for them to work in. The goal that we're going to have is creating a language that can be used by people who don't look at the code behind the scenes and are able to define tests in your application. If we can accomplish that, now we can get to the point where we have people without a lot of technical expertise, but a lot of business knowledge, defining the test cases, working with the test cases, reading them, running them, and learning from them, and building more of them. This will always be more valuable than the people who have the expertise in the testing, because the people with expertise in the testings know the technology, they understand how to deal with Selenium, they know how to write code. They're the people who are looking at this, most likely. But what we're trying to build is a tool for the people who don't have that skill set. So the next parts will be how to implement code that satisfies these scenarios in both C# using SpecFlow and in JavaScript using cucumber.js. Those next two parts should be up soon.